In a bakery, there are more tasks than just making or decorating cakes. The proposal for our project is to create a CNC machine to decorate circular cakes. This to make in a bakery the employee to perform another activities while our machine could be decorating simple or even more complicated designs. Our project will have an interface for the user to choose an image for the cake.
We will use stepper motors in order to make the movements of the frosting in X and Y axis. We will work in a 2D plane. How will we perform these movements? According to the design desired by the client, we will use Arduino interface, that is basically a C++ language. And also we will need the software or extension GRPL that serves as an interpreter for the G-code in the Arduino. So we implement this and it will interpret the movements in X and Y according to the desired design.
For our project, we will make some tests that will make sure that it works like in a good way. One of the tests is a design test in which we will make sure that the image chosen is at least 80% alike as the one in the cake. And also there will be an integration test that makes sure that the electronics and the mechanics are working together and that can perform the tasks. Finally, there will be a communication test that will make like the user and the machine interface and also the connection between all the elements. In the electrical and in the mechanical, that all the motors can move properly in order to make the design. And finally, there will be a communication test that will make like the user and the machine interface and also the connection between all the elements.
Our project will have a human-machine interface made in LabVIEW so that the user can familiarize with the program and watch its design with more facility. Also, the project will have a feature that the user can change the frosting once the design is done with the first one and if it's required to add more frostings to the design. The machine works in the following way. First, the user chooses the design that is wanted. Then, through the program, the coordinates to draw the design above the cake are established. Then the machine makes sure that there is enough frosting to draw the design over the cake. And then, after checking on that, the machine will move the frosting down over the cake and we will begin to draw the design. Then, once it is done, the machine will move it up. And then, the last step will be that if there is more colors, the user will be able to change them one on one in order to complete the design.
Now, we're gonna define the 12 steps. The first step is the simplified interconnection diagram, in which we define our project as a mechatronics project because of the interconnection of the mechanical, the electronical, the programming, and the processing parts.
Now I'm going to explain these interconnections. For example, in the mechanical and electronics areas, there will be the development of the motion, the design of the whole machine, and the maths implied in this process. In electrical and control areas, there will be the development of the filters in order to avoid possibly noises during the process the machine performs. In mechanical and programming areas, we'll work together to make sure the movements of the motors and the mechanisms are being done right. And the control and programmation areas will work together for the data acquisition and processing.
The third step is the mechatronics design transversal layer, in which we have a human-machine interface, also called HMI, and through an Arduino, the image data is processed. And after that, the motors, sensors, and mechanisms start working to make the purpose of our cake decoration. The fourth step is the conventional design, in which we have filters, sensors, actuator models, an Arduino, and a power signal.
The step number 6 is the closed-loop mechatronics, in which we design all the subsystems in interconnection and in a closed loop. In our case, our design or our product will have the actuators, which are in the system or in the prototype, in connection with the sensors, which signals goes directly to the Arduino, which is the processor or the processing unit. Then the control is made to make, again, the system react through the actuators and sensors. So all of this in our system will be interconnected with the user through an interface that we already explained. For the step number 7, which is the individual elements and input constraints, we have in our system transfer functions for the individual subsystems, and just in the case of the interface and the sensors, this will be for data acquisition. The step number 8 defines the category of each module in our system. So we have the hardware will be all the motors and actuators of our product. The software will include the Arduino and the processing of the product. Then the firmware will be the system that interconnects these two parts. And finally, the humanware includes the interface in which the human can interact with the system.
The step number 10 is the humanware, where the human makes part of the closed loop system. He or she chooses the parameters for the cake decoration. So he is the one that makes the categorization, and then that goes through the Arduino and then to the cake decorator, the machine that we are making. That will take out like all the noise and everything, and that goes back to the person, because he's the one that takes out the cake whenever the process is done.
Consists in 3 basic steps. The first step is V-model. To define and explain the requirements for the project. Then compare it to what the client desires and which is the kind of user that is going to use our machine. The second step goes into the technical details, the requirements that are going to be used but explained in a more technical way. The last step will be to compare the initial requirements to the requirements that would be upgraded for the final project. This project has a human-centered design because, as we said previously, direct participation of the human. A user that puts a USB to select the design, and then the machine will just draw it. The next step involves the mathematical expressions, the control systems we are going to use to model the inputs and outputs of the systems. The decision making will conform into parts, as the human part as the robotics part. The human part because the user will have to know when the program is going to stop in order to change the frosting in case it's necessary to keep modeling the design. And then the robotics part to establish the coordinates and know how to perform the moves of the stepper motors. The interaction with the machine for the user will be very simple actually, because it has an HMI, so the user can see what's going on, and also will have a very intuitive system with buttons and USB entry.
In conclusion, we will produce this prototype as a mechatronic design that will integrate the areas of mechatronics to finally get a prototype that will function completely and as the user will expect.